If you look up the flight time from London to New York, it's about 7 hours. But what if I told you that in the 70s, a commercial jetliner was crossing the Atlantic in under 3 hours?
Nose come up to 20 degrees, she's airborne. She flies.
Cruising at twice the speed of sound, Concorde used technology never before used on commercial airliners. Concorde redefined jet travel forever, albeit short-lived due to a number of economic, environmental and technical issues. Nothing quite like this marvel of engineering had flown before, and nothing has come close to it ever since. This is the extraordinary engineering that went into designing, building and flying Concorde. Imagine hopping onto an airplane in London, enjoy a glass of champagne and a fancy meal, and in just 3 hours landing in New York. In the 1950s and 60s, jetliners such as the Boeing 707 and the Havilland Comet were unveiled to the world. These aircrafts showed that long-distance air travel could be comfortable and efficient, unlike the noisy war-era piston-powered aircrafts that dominated the post-war world. But jetliners weren't only more comfortable and quieter, they were faster, much faster. With a piston-engine aircraft such as the Douglas DC-6, a flight from London to New York was a grueling 13-hour journey. Jetliners like the Comet slashed flight times in half, at around 7 hours. The jet engine proved that commercial aviation could be comfortable, but something much faster was right around the corner. Throughout the 50s, supersonic airliners were considered possible on the drawing board. Countries such as the US, UK, France and Russia were all developing their own supersonic airliner. By the way, I'll be covering the US and Russia supersonic airliners in separate video, and I promise you're gonna wanna watch them. Both France and the UK had quite similar designs for a supersonic airliner. Both adopted the delta wing design and 4 underwing engines. By the early 1960s, designs were finalized, but due to considerably high costs of production, the Bristol Aerospace Company and Sud Aviation eventually merged in 1962 to develop Concorde. Fun fact, this merger of companies is still alive and growing today as Airbus. Delta wings allow an aircraft to decrease its wingspan dramatically and reduce drag significantly in supersonic flight. However, in subsonic flight, particularly in takeoffs and landings, they struggle to generate enough lift to get the plane off the ground. This is where Concorde's iconic ogival delta wings come into play. Concorde's wings have 2 sections, the forward section having a higher swept area than the rear section. This wing design allowed Concorde to generate extra lift at low speeds. But to achieve the amount of lift required at takeoffs and landings, Concorde needed to have a high angle of attack. This could be seen more clearly side by side to a conventional subsonic airliner. This high angle of attack created an issue with pilots' visibility. Engineers eventually solved this issue by the so-called droop snoop, essentially lowering the nose of the plane by up to 12.5 degrees, so that pilots could visually see the runway. While subsonic jetliners cruise at around 35,000 feet, Concorde soared at an altitude ceiling of 60,000 feet. Passengers on board could glimpse the curvature of the Earth while cruising at Mach 2, twice the speed of sound. Passengers, however, could notice another feature on the airliner. Every surface, such as the windows, were warm at these high altitudes. Concorde's surface was susceptible to aerodynamic heating, a phenomenon which occurs as a body moves through the air at high speeds. Finding a material to withstand these temperatures while also being cost effective is more difficult than you think. Titanium, which was used on the SR-71, was excluded early on due to its high costs. This led to the implementation of hidiminium, an aluminium alloy developed for Rolls-Royce for World War II military aircrafts. It was chosen as it was relatively cheap and workable. An interesting fact is that Concorde had livery restrictions. The majority of the plane surface had to be painted with highly reflective white paint to reduce the temperature of the airframe underneath. In fact, the white paint reduced the plane surface temperature by up to 11 degrees Celsius. Modern commercial aircraft such as the Boeing 777 rely on high bypass turbofan engines for fuel efficiency and noise restrictions over land. Concorde, however, required a different solution for its propulsion systems. Turbofan engines were ruled out early on because of the large cross-sections required, resulting in high drag. By the way, I've made an in-depth video on turbofan engines. I'll leave the link to it in the description below if you want to learn more. You see, fuel efficiency and supersonic flight are two opposing terms, but there was one solution available. The Rolls-Royce Olympus 593 was the ideal candidate for Concorde. The overall efficiency of the engine in supersonic cruising flight was about 43%, which at the time was the highest efficiency attained by any engine. The four engines combined produced an astonishing 152,200 pounds of thrust at takeoff. The engine was already in development and met the design requirements of Concorde. The brilliant design of the exhaust nozzle allowed Concorde to operate efficiently in all stages of flight. Variable nozzle configurations changed the exhaust exit area, resulting in optimal efficiency throughout the flight. Variable airflow was also implemented in the engine inlets. The air intake design of Concorde was unlike any other commercial airliner. Most commercial aircrafts use a fixed air inlet design. This is because they operate at lower subsonic speeds. At Concorde's cruising speed of Mach 2, the air injected into the engines would be devastating, as no engine could operate with supersonic airflow. Thus, before being injected into the engine compressor, air had to be slowed to subsonic speeds with high pressure. To achieve this, Concorde's square air inlets integrated a series of ramps and doors to control the flow of air directed into the engine compressors, depending on the stage of flight. For example, during takeoff, the engine required all the air possible to generate maximum lift. To power the four Olympus 593 engines, Concorde had 13 fuel tanks in total, formed within sealed cells in the wings, center, and rear fuselage structures. Without the full capacity of 119,000 liters of fuel, Concorde's transatlantic flights wouldn't be possible. Fuel transfer between the tanks was crucial to control the fuel's temperature and pressure. The color coding of the tanks indicates their main uses. Red tanks feed the four Olympus engines. Blue tanks are the main transfer tanks, which ensure that the main red tanks are filled constantly. The blue tanks are situated around the center of gravity of the aircraft, ensuring that no center of gravity changes occur during inter-tank fuel transfers. Green tanks are the trim tanks. Their main job is to shift the center of gravity by up to 5 feet during transonic flight. You see, Concorde, unlike other commercial aircrafts, does not have a rear tail. Subsonic commercial airliners control the pitch of the aircraft by adjusting flaps on the rear tail. However, Concorde's design could not easily integrate elevators to the delta wings, which would have caused high levels of drag at high airspeeds. Thus, the green transfer tanks are essential for the trim or pitch control of the aircraft.
Mach 2, twice the speed of sound.
As the plane edged closer to its cruising speed of Mach 2, fuel was transferred from tanks 9 and 10 in the center fuselage to tank 11 in the rear, shifting the center of gravity of the aircraft. I can't help but wonder what a flight on Concorde would have been like, as I was born just 2 years before it was eventually retired in the end of 2003. The fate of Concorde is somewhat tragic, to say the least. Although being ahead of its time, environmental and noise-related concerns arose during its lifetime. Excessive emissions and sonic booms led to protests by governments and general public. However, Concorde's main issue was one of economics. Rising fuel prices in the 70s coincided with the introduction of Concorde, leading to all airlines withdrawing their orders except for British Airways and Air France. Concorde would go on to serve these two airlines for close to 3 decades. This, however, wouldn't last. A fatal crash in July 2000 hindered Concorde's impeccable safety record. Then along came September 11th, which wreaked havoc on all commercial air travel worldwide, leading both airlines to cease operation of the world's only supersonic airliner. Or was it? There was in fact a Russian Concorde which entered service before the actual Concorde, which I'll be covering very soon. If you want to learn more about jet engines, I highly recommend you watch this video. Let me know what you think in the comments below. Thank you very much for watching, and I'll see you in the next one. Bye guys!